I've been making props and replicas for a long time. And I mean a long time. It's honestly crazy to think how far I've come. Like, as a kid, I made this Iron Man helmet out of paper mache. Then eventually I graduated to using cardboard and resin. And now we've taken things to the next level with the help of, well, 3D printing. 3D printing. That's right. If you've been a long-time viewer of this channel, then you definitely know that's a bit of a bad word around here. 5 years ago, when I made this Iron Man helmet, I said this.
Over the years, there have been some really talented people all over the internet making Iron Man helmets. Most of them, however, use servos and coding and electronics and 3D printers.
But you guys know that's not my style. Yeah, that didn't age well. So yeah, I used to make it a pretty big deal that these projects did not involve any 3D printing. I wore it like a badge of honor. So what's changed? Well, back then, to be honest, 3D printing kind of felt to me like this niche fringe hobby that you would only find on the corner of Reddit. Sorry if I just offended you. But now 3D printing is like so ubiquitous, and it's so much cheaper, faster, and easier than ever before, which is the main reason I've grown to love the hobby of 3D printing more and more. So today I want to show you how I 3D printed, painted, and motorized this Iron Man helmet. Honestly, this build came with so many challenges. There's a lot that goes into making a helmet like this, and in this video I want to show you all of that, and hopefully by the end of it you'll walk away feeling like you learned something new, and maybe even want to make your own Iron Man helmet. Okay, first things first, let's open up the laptop so we can download the STL files. I purchased the STL files from this website called Wireframe. Now, you can either buy the whole entire Mark 47 suit, or you can buy just the helmet by itself, which is cheaper, of course. I went ahead and just bought the whole suit because I feel like I might want to make the whole suit after this, but it seems like a pretty big commitment, so I don't want to make any promises. Maybe I'll make it, maybe not. I guess stay tuned and find out. Anyways, now that I have my STL files downloaded, the next thing we need to download is Bamboo Studio, which is the slicer we're going to use. After that's been downloaded, we can open up this Bamboo Studio application, create a new project, and then drag these STL files into Bamboo Studio. Before printing this helmet, we need to figure out what size to print at so that it fits properly. And that's where these come in. These are cosplay calipers, which you can find on MakerWorld in the Bamboo Handy app. If I measure the widest part of my head, you'll see that it comes out to about 160 millimeters, give or take. Now that I know how wide my head is, we can scale the helmet accordingly. So let's go back to Bamboo Studio, and if we click this scale button, we can see that the distance between this red dot and this red dot is 187 millimeters. Now that represents the outer diameter of the helmet, but if we want to take it one step further and measure the inner diameter of the helmet where the opening is, we can click this measure tool, and that allows us to measure the distance between any 2 points. As you can see, the inner diameter measures around 162 millimeters. Well, would you look at that? I guess we won't have to scale the helmet down after all. I have a pretty small head, so that's a first. Knowing how small my head is, I imagine some people are gonna have to scale this helmet up. So another good way to gauge the fitment of the helmet is to use a mannequin head that is scaled to match the dimensions of your head. Or better yet, just use an actual 3D scan of your real head. All right, it's time to prepare the 3D files for printing. See how this piece is floating at a weird angle? Well, to fix that, you can either click this rotate button and rotate it manually, or you can click the lay on face button, which is typically the way I prefer to do it. This button basically shows you a bunch of faces, and you can choose which face to snap to. Some of these pieces need to be printed more than once and or mirrored. So here's a list that lays it all nice and neatly for you. You're welcome. In order to create a mirrored copy of something, just right click, hit clone, then right click again and click mirror, and we're going to mirror along the x-axis. Boom, done. Now that I have all the pieces laid out on the bed, I'm going to enable supports, and everything else is just going to be left on default settings. In total, there are 20 different STL files to print, but luckily I have 2 different 3D printers I can use at the same time. Only problem is there's 3 separate print jobs that are required to print this helmet. Man, if I had a third 3D printer right now, that would really... This is the brand new Bamboo Lab P2S. They're calling this printer the Icon, redefined. It's basically everything you love about the P1S, but, well, better. Unboxing and assembling this printer was a breeze. It literally feels like a microwave. Like, you just take it out of the box, plug it in, screw a couple things, and it basically works perfectly right out of the box. So I got to printing my Iron Man helmet right away, and the first upgrade I noticed was this big, beautiful touchscreen, which of course we didn't have on the P1S. This was a much needed upgrade, and it's such a joy to use. Something else you'll also appreciate is this quick swap nozzle design, so now it takes 10 seconds to swap nozzles instead of 10 minutes. Oh, and did I mention the HD camera? Yeah, this camera paired with the super bright LEDs is great for time lapses or monitoring your live prints. If you're interested in learning more about the Bamboo P2S, check out the link in the description. Also, just so you know, Bamboo Lab is running a big Black Friday sale, and some of their stuff is the cheapest it's ever been, so if you've been thinking about pulling the trigger, now might be a good time. This helmet disassembles into 2 parts held together by magnets. The instructions say to gently heat the holes for the magnets using the soldering iron and press them into place. To be honest, I have no idea what that means, and even if I did, I'm pretty sure I would mess that up. So I just used a knife to trim off some of the PLA and then super glued the magnets in place, and that worked perfectly. The next thing we have to do is get these earpieces to fit in the helmet. At first, I thought I was crazy because I was like, why don't these fit? And I started thinking maybe I messed up the scale when I was showing you how to use the scale button, but then I found somebody else who made this helmet, and I zoomed in on their helmet, and I saw that they also had to trim this part of their helmet too, so I guess I'm not crazy after all. These 2 little nuggets, you'll see what these are for in just a second, but first we have to install these M3 by 5.7 by 4.6 brass heat set inserts. Don't ask me what all those words and numbers mean, that's just what the instructions call for, so I ordered them on Amazon, which I'll leave a link to below of course, and I set my soldering iron to 400 degrees Fahrenheit before carefully melting these into the holes. This right here is the helper arm. If you don't know what a helper arm is, it's basically the term that people use to refer to the little arms that pivot and help guide the faceplate to open and close smoothly. These screws are going to pivot on those brass heat set inserts I showed you a moment ago. Now, see how this arm is curved, almost like an S shape? Well, the orientation does matter here, so you have to make sure that this piece goes on this side and this piece goes on this side. Once we've done that, we can install these into the helmet. So I'm going to temporarily tape the faceplate to the dome, and if you take a look inside, you'll notice that these little pockets right here line up perfectly with the helper arm. Let's go ahead and sand these surfaces a little bit so that the glue adheres better. And right before I glue this helper arm into place, I'm going to tighten these down all the way, and then from there, loosen them by about a full turn. This is because as the faceplate opens, it actually tightens the screws down, so we need to give the screws a little bit of leeway. This part right here can be a little tricky because you need to make sure that the slanted surface is laying flush, but one thing you can do to help is just look at the 3D model, and that will help you be able to visualize the orientation better. Once I had that all figured out, I super glued this helper arm in place, and for the other side of the helmet, you actually don't need to loosen the screws because this side is pivoting in the opposite direction. Okay, I have to admit, that step was actually harder than it looked. It took me multiple attempts to get this faceplate to align properly. At first, it was getting stuck and it was just crooked and everything, but here's what I did. Okay, so I took the faceplate off and then I glued the arms on like this. That way I can see if it's traveling straight, because you want these arms to travel like straight up and down, literally straight up and down like this. If it's like tilted at an angle or like crooked like this, then that's what's going to give you issues. The problem with the way I was trying to do it at first is I had the faceplate taped on like this, and when you have the faceplate on, it kind of makes it difficult to see what angle these are being glued at. So I recommend not doing it the way I showed you earlier. Just do it like this with the faceplate off and it'll probably be a lot better. At this point, I noticed that the faceplate was kind of clipping right here, like there wasn't enough clearance, and apparently this is somewhat of a common thing with Iron Man helmets, so no big deal, we can just sand it down and voila. This is the Alicia MKE Mini. It's basically a little brain that will control the movement of the faceplate. Some people might use like an Arduino for this, which is fine, but this Alicia MKE Mini board is faster and easier because you don't have to program it and you also don't need to solder too many things, so it's a very straightforward plug-and-play experience. Speaking of plug-and-play, let's plug these MG90S servos in. These servos basically have a little gear that rotates, and that's the thing that's going to physically move the faceplate. See these black and red wires? Well, those are for the LED eyes. Since I want the eyes to glow like it does in the movie, I ordered these ice blue LED cosplay eyes on AliExpress. Now, depending on where you are, you might want faster shipping than AliExpress, so you can also find these on Amazon as well, but last I checked, it's literally like quadruple the price. I'm gonna go ahead and cut off the battery pack here because I want to connect these LED eyes to the Alicia MKE Mini, and the reason for that is because the Alicia MKE Mini is programmed to turn the LED eyes on when the faceplate is closed and off when the faceplate is open. All we have to do is solder the red wires together and the black wires together. So we simply twist them together. By the way, don't forget to slide that heat shrink tubing on beforehand. Then add flux, add solder, and then finish it off with some heat shrink tubing. So let's recap. So far, we've established that the Alicia MKE Mini is like the brain. It tells the servo to rotate back and forth and also tells the LED eyes to turn on and off. So now we just need something that will trigger those things to happen. And that's where this limit switch comes into play. Notice there's C, NO, and NC. We're just gonna solder these blue wires to C and NO. It doesn't really matter which wire goes to which terminal as long as one goes to C and one goes to NO. Basically, whenever you press this limit switch, that will send a signal to the Alicia MKE Mini, and that way it knows when to trigger the servos as well as turn the LED eyes on and off. At some point, we're gonna position this limit switch right beneath the chin area so that you can push the button just by moving your chin forward, but I'm getting ahead of myself. So now we just need to figure out a way to power everything with a battery. So for that, I'm gonna use this 5-volt 2.1 amp power bank. Now, there's a couple different ways we can go about doing this. The easiest way is just to take this cable right here, which comes included with the Alicia MKE Mini, and then simply solder a USB cable to it. Then take this and use it to connect the power bank directly to the Alicia MKE Mini. If I press this limit switch, that will turn the LED eyes on and off, as well as rotate the servos back and forth. Here, I'll hold it up to my mic so you can hear it. As you can see, everything is working fine, but there is one problem, which is that a lot of power banks, including the one I'm using, have this like auto shut-off feature, which basically means if the amount of current being drawn from this power bank isn't meeting a certain threshold, then after a minute or two, the power bank will just shut off by itself. As you can see, the LED light just turned off. That actually was perfect timing. Because that power bank just turned off, you'll notice that when I press the limit switch, nothing happens anymore. Unless, of course, you unplug the power bank and then plug it back in, but that's pretty inconvenient. So the solution to all this is actually pretty simple. Let me explain. Basically, when you buy this Alicia MKE Mini, you'll have the option to purchase it with or without this. This is the Penelope board. Basically, how this Penelope board works is it's very simple. All you do is plug this Penelope board into the Alicia MKE Mini and then plug the Penelope board into the power bank using a mini USB cable. And once you do that, the Penelope board makes it so that the power bank is always outputting a little bit of current. That way it doesn't shut off by itself, which is exactly what we want. There's one very last thing I'm going to solder, which is this little rocker switch. That way I can turn the whole thing on and off by pressing that switch instead of having to plug and unplug the USB cable from the power bank. Basically, we can just solder that rocker switch to the red wire of the USB cable, and again, it doesn't really matter which wire goes to which terminal. We're going to use those same brass heat set inserts I showed you earlier, except this time, for some reason, the hole is too small here. At first, I thought maybe I was doing something wrong, so I DM'd Levy 3D, which is the guy who 3D modeled this helmet, and he said, oh, I didn't realize it was too small. So that was really nice of him to reply. And by the time you're seeing this video, maybe there's a chance he updated the files, I don't know. But either way, it's fine because I just drilled a bigger hole and it worked out. Remember earlier how I showed you the helper arms? Well, there's actually 4 arms. 2 of them are helper arms and 2 of them are servo arms. This arm you're looking at right here is the servo arm. This is the arm that's going to be directly connected to the servo, hence why it's called the servo arm. Now, just like with the helper arms, these servo arms are going to be pivoting on those brass heat set inserts we just installed. And again, as the faceplate opens, one side is tightening while the other side is loosening, so you need to adjust the depth of the screw accordingly. Also, just so you know, the mirrored version is supposed to be on this side. I'm not exactly sure if that makes a big difference, but since those servo arms are not exactly symmetrical, I'm assuming it does make a difference. Included with your MG90S servo, you'll find a little screw and a little arm here, and this arm is supposed to be able to fit into this spot right here, but somehow it didn't fit. So I just removed some material with my Dremel and a burr bit, and that did the trick. This little arm that came included with the servo, that's what's going to allow us to connect the servo gear to the 3D printed arm. So all we have to do is take those little arms that came included with the servo, and those have a gear hole on them. So you just have to line that gear hole with the gear teeth and then tighten it down with the screw that came included with the servo. Now notice how the arms are positioned at a bit of an angle there. That's really important. You really need to make sure that it's at that exact angle. And it shouldn't be that hard to figure out because you're aligning a gear hole with gear teeth, so there's only so many positions you could actually have it at. Before gluing this into the helmet, I'll just sand the surfaces a bit, which should allow the glue to adhere better. And let's position it right about there. Oh, okay then. I wasn't sure what was going on here, so I ripped the whole piece out so I could start over, and after hours and hours of trying to figure out what happened and what I was doing wrong, I kid you not, this kept me up at night, I finally figured out that there just wasn't enough clearance right here. So we just have to remove some material, and notice I'm standing at a 45-degree angle here. That's so that you can't see from the outside that I've removed some material. If I had known that this was the problem earlier, it would have saved me so much time. So yeah. See that? See how much more clearance we have now? Well, now I can re-glue the whole thing back into the helmet, and hopefully this time it'll work. Okay, so I was able to get this to open, but for some reason it won't close. Well, actually, I think I do know the reason. I think it's because I glued this a little bit too far forward. I think this needs to be glued a little bit further back this way. And I'll see if that helps. This time I was careful not to use too much super glue just in case I had to rip it out again, because the first time I did this I used so much super glue that it took forever to rip this thing out. And yeah, you can always add more glue later once you've positioned it correctly. Well, I think I got it working now. The only problem I have now is it doesn't close all the way. You see that? You see that little gap there? See that? So I think what I need to do is just add a magnet to make it snap shut, and that should do the trick. We're using the exact same 10x2 millimeter neodymium magnets we used earlier, and sure enough, this magnet was the perfect solution. Now that I added the magnets, the motorization actually works pretty flawlessly. I have to say, getting to this point was a lot harder than I expected, especially because of all that trial and error I had to go through. Like, what you saw on camera was really just a condensed version of what actually happened, which is that it took me like a few days to figure out how to get this to work. If I'm being honest, I actually almost gave up on making this helmet open and close. At one point, I even reached out to my friend Cranshark for help, and he basically said, well, Sean, sometimes 3D printers produce different results, so maybe you need to sand or trim a few things to get it to fit properly, and he said that that was normal. And you know what? He was right, because I actually printed a second copy of the helmet just as a test, and you can visibly see that the two helmets turned out a little bit different. See how the first helmet has a little bit of an offset? Well, I think that just goes to show that every print is kind of like its own experiment, and some of the issues I face may or may not appear in your build. Either way, sometimes 3D printing requires a little bit of problem solving, but if you stick with it, I'm sure you can figure it out, and hopefully some of the things I share in this video will help you get there faster. Now I can move on to post-processing. Post-processing is just a fancy word that means taking a raw 3D print with all its layer lines and whatnot, and gradually turning it into a smoother, more refined finished product. I'm not going to sand the whole thing because that'll get taken care of later. I'm just going to sand the parts that are really, really rough with 80 grit. Now on this dome piece, you'll notice there's quite a bit of stair-stepping right here, and you might be tempted to just want to sand this down, but the problem with that is we have a detail line right here. And if we sand this down, there's a good chance we're gonna lose that detail. Another thing that some people might think to do in this situation is just lay on a really thick layer of filler primer. But again, if you do that, then you'd be filling in this crevice right here, and that makes it difficult to preserve this line. So we're gonna use some Bondo body filler. Basically, this is part A and this is part B, and when you mix these two together, that kicks off a chemical reaction, and from there you have a few minutes before this hardens up. Once it fully hardens, it becomes very hard and rigid and solid, and you can sand it smooth. I should mention that this step actually could have been avoided altogether. All you would have to do is specify in Bamboo Studio that you want the top of the dome to print in a lower layer height, and that way you wouldn't end up with as much texture. But perhaps that's something to consider for a future print. Okay, you want to know what's shocking? I see so many people who 3D print things on the regular, but instead of investing in an HVLP setup, they just burn through those $20 rattle cans of filler primer. Honestly, I was that way before because I didn't even know what 2K high build primer was, but now that I do know what 2K high build primer is, I literally feel like it's my duty to share this life-changing thing with you, alright? Yes, I know an HVLP setup has more of an upfront cost, but once you start using 2K high build primer, I promise you'll see how much faster and more cost effective it really is. So if you can get an HVLP setup, I really, really do recommend it. And listen, I have nothing against using rattle cans. In fact, I'm literally using one right here. But when it comes to primer, 2K primer is just simply superior. It literally just takes one layer of 2K primer and then one pass of sanding with 320 grit, and you're done. That's it. Versus with the rattle can, you'd have to go over it like 100 times, and then each can costs like 20 bucks. So yeah, shout out to Offer 3D. He's the GOAT because he showed me what 2K high build primer is. If you have no idea what I'm talking about, that's okay. All you need to know is that the gray paint I just used is basically just a really, really thick paint that fills in all the layer lines and makes the whole thing look smooth. Then I sanded with 320 grit, and now I'm painting all the pieces black. Why are we painting all the pieces black, you ask? Well, there's 3 different colors on this helmet. There's metallic red, metallic gold, and chrome. All 3 of these colors require you to start with a glossy black surface. So as you can see, in order to make the surfaces glossy, I'm spraying a 2K clear coat. 2K just means 2 component, so like with the 2K primer, we mixed it in a 4:1 ratio. And with this 2K clear coat, it's the same thing. We mixed it in a 4:1 ratio as well. Some paints have a different ratio, so just check what it says on the can. Something I had to learn the hard way is that 2K clear coat actually has a pretty short shelf life. So like I bought 2K clear coat in bulk thinking I was saving money in the long run, but all of my hardener went bad and I was like really sad. But I'm just passing that information along with you in case someone finds that information useful. If you look closely, you'll see we got a little bit of a paint run right here, which just means we applied the paint a little bit too heavy and it dripped. But it's not the end of the world. There is a way to fix this. All we have to do is sand this down with some very fine sandpaper, and then after that we'll apply compound and polish. See that little piece of masking tape right there? Well, that's just there to protect the edge, because if you spend a little bit too long applying pressure on that edge, it's really easy to burn through the clear coat. As you can see, it already looks pretty good after the compound, but the final step is to apply the polish, which is even finer and meant to completely bring back the shine. Unfortunately, I got a little too excited and I got a little bit of a burn through right there. You can see I lingered on that spot a little too long, but it's alright because we're going to weather this whole thing later on anyway. Okay, so now it's time to paint all the pieces chrome, and for that I'm going to use these paints. This one here is called Ultralumen, and this one is called Alumoluster. The only piece we don't need to paint chrome is this one right here, but everything else needs to be painted chrome because in order to achieve a metallic red and a metallic gold, we're required to start with a chrome base coat. In case you're wondering, the Ultralumen is a little bit more reflective than the Alumoluster. Basically, the plan is I'm going to spray this Ultralumen on all the pieces that are going to be painted gold because I really want that gold to like pop, you know, and then everything else is going to be sprayed with Alumoluster. Now, just to be clear, you really don't need 2 different chrome paints. These are expensive, so even if I just had one of these, it would be totally fine. It's just that this Ultralumen was sent to me as a gift from the Digital Armory, so shout out to the Digital Army. Thank you for sending this. This paint, I've been so excited to try it because I've seen videos of it. I haven't tried it, but this is literally like the most reflective chrome paint I've ever seen in my life, so I'm super pumped to try it. The instructions for the Ultralumen say to use the smallest nozzle you have, so I'm using a 0.3mm nozzle on my airbrush and spraying at about 30 psi, and after a few coats, it looks amazing. Now for the Alumoluster, I find that it's a little bit more forgiving than the Ultralumen. Like, you don't really need to worry too much about nozzle size or psi, at least in my experience. Maybe I'm wrong, but I find that it doesn't really make that big of a difference in the end. The Alumoluster dries to the touch almost immediately, whereas the Ultralumen, I don't even know if it ever fully dried, to be honest. It takes forever, but man, I can't get over how amazing that Ultralumen looks. For all the pieces that are going to be painted red, I applied some liquid latex wherever I wanted there to be a paint chipping effect. Basically, all the areas that are covered with latex are going to stay chrome and appear chipped. On the other hand, for the gold parts, I very, very lightly grazed the surface with a soft Scotch-Brite pad so that in the end it'll have a brushed metal look. You can't really see it from far away, but when you get close, you definitely notice it. Be very, very gentle with the Scotch-Brite pad because literally every little scratch will show in the final product. Ask me how I know. The first time I tried this, I applied way too much pressure, and in the end I had to dissolve the paint down to the clear coat with isopropyl alcohol so I could restart. So you definitely don't want to do that. As I mentioned before, the red, gold, and chrome all require a gloss black base coat. In the case of the red, this red won't look metallic unless it's sprayed over top of a chrome surface, and the chrome won't look chrome unless it's sprayed over gloss black. So that's why we have to spray all those layers in that particular order. This red paint is extremely thin and watery, so you have to spray it in very light coats, waiting a few minutes in between each coat. For the gold paints, I wanted to try these, but the website doesn't ship to Canada, so I DM'd Imperial Surface and asked if I could pay extra to have it shipped here, but he just sent them over to me as a gift, so thank you, Sam from Imperial Surface. And I also have to thank you guys for watching, because these things wouldn't happen if it wasn't for you guys watching. After trying 5 different golds, I eventually decided to settle on this one right here called Bullous. And how this gold paint works is it's not really like a paint, it's more like a dye that you mix with a clear coat, and then you spray that over a chrome surface. The instructions say to mix it with a 2K clear coat, but I actually saw a video from Offer 3D where he mixed his with All Clad Aqua Gloss Clear, and I was like, wow, that's genius, and I tried it, and it worked. There's a lot of different reasons why someone would rather use All Clad Aqua Gloss Clear instead of 2K Clear, but For me personally, it just seems a lot less scary because, I don't know, 2K clear coat is just really thick and harder to apply, and also if you mess up you can't just wipe it off like you can with all clad. Now there is one caveat though, which is that anytime you deviate from the manufacturer's instructions, that's when you get unpredictable results. So it shouldn't come as a surprise that 2 out of the 5 golds that I tested were actually not compatible with the all clad aqua gloss clear, namely the ones called Lost City and Devil's Blood. For some reason, I don't know why, but they didn't react well with the all clad. I just kept getting like big chunks forming in the clear coat, and I tried to do multiple tests to make sure it wasn't just user error, but every time I did it, I got the exact same results. So the takeaway here is always test, especially if you're deviating from the official instructions. Did you know in Romans 8:28 it says, "In all things, God works for the good of those who love him"? What that verse is saying is even when things don't go the way you planned, even when you mess up or life throws a curveball, God can still use all of it for good, if you'll let him. And you know what? That's kind of like what's happening with this Iron Man helmet as we weather it. You see, this helmet has a bunch of imperfections on the surface. There's definitely some mess ups, like for example, a few dust nibs that got trapped in the paint, or spots where finger oils contaminated the surface, and even that spot where I accidentally burned through the clear coat earlier. None of those things were intentional, they were just bumps that happened along the way. But in the end, we can actually use those imperfections for good by incorporating them into the weathering. Like, you see this little dust nib right here? Well, by placing the paint chip right there, it makes it look even more convincing because it's almost like the paint is physically peeling up. Or remember when I accidentally burned through the clear coat right here? Well, that ended up blending in really well with the rest of the weathering, and it actually looks pretty good because it gives it a bit more variety. And just like the surface of this helmet, our lives are full of mistakes and imperfections. But the beautiful thing is, God can use all of it for good, and I mean all of it, if you'll let him. You know, I usually like to keep things pretty chill and lighthearted on this channel, but I'm going to share something a little personal if you'll let me. Recently, someone really close to me was diagnosed with pancreatic cancer, which is one of the scarier types, and honestly, I've never lost anyone close to me before, so this news was just shocking. And as much as I want this person to make a full recovery and, you know, live a long, healthy life, I'm also kind of, well, at peace because this person I'm talking about, well, they gave their life to Christ a long time ago, so even if their time on earth ends sooner than I want, I know it's not really the end. The reason I'm sharing this with you is I want to remind you that our time on earth is short. The most important question you can ever ask yourself is, what's going to happen when I die? A lot of people think nothing happens, or I don't know what happens. If that's you, listen, I don't want you to find out the hard way that you were wrong. I need you to know today that hell is a real place, and those who haven't given their life to Christ are headed there. I know, that might sound bizarre, but you know what's even more bizarre? Thinking that the Bible is corrupt or fabricated or unreliable. I mean, do you really think it's that simple? Really? I mean, really? Or is it that you just don't like what it says? You know? Come on now. I know this was quite the rant, but I want to leave you with John 3:16, which says that God so loved the world that he gave his one and only Son, that whoever believes in him shall not perish but have eternal life. Well, once I was satisfied with the weathering, I hit all the red, silver, and gold pieces with one final coat of 2K clear to seal the deal. And just to recap, here's all the pieces we have. So we have the red pieces, the chrome pieces, that one black piece, and the 2 gold pieces. This piece right here, we're going to make it removable with magnets. I'm actually not sure if the 3D modeler meant for this piece to be removable or not because there's no mention of it in the instructions, but I'm assuming that's what these holes are for. Either way, the helmet doesn't slide over my head unless I take this piece off anyway, so yeah. Next up, we're going to glue these 2 pieces together like this. I think that skinnier piece was actually supposed to be left chrome instead of being painted red, but it didn't really matter in the end anyway, because, well, you'll see. Alright, now we're going to glue those chrome ear pieces to the inside of the helmet with some super glue. And we're going to do the exact same thing for this black eye piece right here. We're going to glue that behind the faceplate. Here, it's very important to hold the faceplate at an angle in a way where the super glue won't drip down and show from the front. For the LED eyes, I used a low temperature hot glue gun. Yes, low temperature because we don't want to melt the PLA or anything. At this point, we can attach the faceplate back onto the dome. So I just screwed the helper arms back on and I dropped some super glue on all 4 screws because those will come undone otherwise. Also, careful not to add too much glue on the servos in case you ever need to replace those in the future. See this gold chin piece right here? Well, the surface area where the glue will bond is pretty small, so we're actually going to use a stronger adhesive than super glue called 3D glue. From what I understand, this adhesive kind of melts or like chemically bonds the 2 plastic surfaces, so that means we can't have any paint on the surface. We have to scrape it all the way down to the raw plastic for this glue to work. It works a little bit like contact cement where you apply the glue on both surfaces and then press them together. I also used 3D glue for the little cheek pieces here for the same reason. I want to thank 3D glue for letting me try this glue. They were really nice and sent over a nice little care package with some 3D Gloop and merch, so shout out 3D Gloop. Now, they actually make a version of 3D Gloop for PETG and ABS and ASA as well, so there's something for everyone. Speaking of ASA, now that I have my Bamboo P2S, it might be a good idea to try printing with ASA one of these days, since that printer is very well equipped to handle that kind of thing. If you print with ASA, fun fact, you can actually do something called acetone smoothing, which is when you place your 3D printed piece inside a sealed container with a little bit of acetone inside the container, and then the fumes from the acetone actually kind of melt and blend the layer lines together, so you end up with a smooth piece without having to prime or sand. When printing with ASA though, the temperature is much more critical, so that's where something like the P2S really shines. Well, I've gone ahead and put all the electronics and wires into the helmet now, and I gave it a little test fit, and the helmet does fit, but unfortunately this back plate does not fit onto the helmet while my head is inside. I think that's because this battery pack is just taking up a whole lot of room in there. So I think what I can do is just remove one of the layers, because right here you can see this is 2 layers thick. I'll just rip one of the layers off, and that should give me just enough room for my head to fit. Sure enough, when I removed that one layer, that gave my head just enough room to fit, and now it literally fits perfectly. The helmet looks a little large from the outside. I think that's just because I have a small frame though, because even though it looks large on the outside, it feels very tight on my head. This thing turned out so good. I am so happy with how this looks. Look at that. The red and the gold and everything just looks so good. I don't know about you, but my favorite suit is the Mark 47. I just think the silver looks so good, and I feel like that suit doesn't get the love it deserves. I feel like I want to make the whole suit now. I don't want to make any commitment, but this is just so sick. I feel like I have to make the whole suit now. Now, there's actually 2 pieces I did not glue in the helmet, which are these right here. That's because I have no idea what color these are supposed to be. If anybody knows, let me know. These are supposed to be glued like right up here in here. But once I figure out what color these are supposed to be, I'll finish and paint them and then glue them in. But until then, that is how you make an Iron Man Mark 47 helmet. If you enjoyed this video, then check out my previous video where I made a Spider-Man mask with moving lenses. Thank you very much to my patrons for supporting me on Patreon, and thank you for watching.